Hey everyone, welcome to Topper Study, your one-stop solution for all your JEE preparations. So good evening everyone, how are you? Good evening all the students, I hope I'm audible for you. So guys, today we are going to discuss the concepts of monotonicity and maxima and minima of the function. Okay, so in today, at 12 p.m. session, we have discussed about the concepts of which one, the concepts of equation of tangent and normal, and also we have discussed about the concepts of mean value theorem and also rate of change of quantities. So in today's session, so right now we are going to discuss about the monotonicity and maxima and minima of the functions in detail. Okay, so good evening everyone. Hello Sachinda, good evening. I hope I'm audible for you. So let me start the session guys. So let me tell you, this is a very important topic, monotonicity and maxima minima of a function. Guys, every year, from this particular topic, the questions are asked from application of derivatives. As I told you, you can expect one question every year in your JEE main examination, and specifically from the concept of maxima and minima and monotonicity of the function, you can actually, there are high chances of the questions coming from this topics, guys. So, this is a very important topic. So today, let us quickly revise the concepts of monotonicity and maxima and minima of the function. They're going to be easy. The questions are also going to be easy. You have to understand the concept. First, you need to understand the concept of what is monotonicity of a function going to be, what is going to be maxima, what is going to be minima, local maxima, global minima, global maxima. All these concepts, once you understand it, no, then applying the concepts will not be that big a deal for you. You can easily apply those concepts and get the solutions. So chalo yaar, start karenge. Let us start the session today, guys. So let me first give you a very short intro about myself, if anyone doesn't know me here. Okay, so guys, this is Goutham. I'll be your mathematics faculty. I have done my graduation from IIT Surat, and I've been teaching from past 4 years, in fact, more than 4 years, Abhito. Okay, and I've taught almost 10,000 students, both online as well as offline. So let us start the session then. Let us start the session, everyone. So the first topic which we are going to do, which we are going to discuss in today's session, is going to be related to the concept of monotonic functions. Okay, so now first you need to understand what are monotonic functions going to be. The functions which are going to be increasing functions or decreasing functions, or let us say strictly increasing or strictly decreasing, those type of functions are known as monotonic functions, everyone. Okay, so what are the monotonic functions going to be? Again, I'm telling you the functions which are going to be either increasing or strictly increasing or decreasing or strictly decreasing. Those type of functions, we call them as monotonic functions. Okay, now let us try to understand what is the meaning of increasing function, strictly increasing function, decreasing function, strictly decreasing function. For that, I want everyone to look at the graph. From this graph, you'll be easily able to understand, what is the difference between increasing, strictly increasing, decreasing, strictly decreasing. So guys, you see this graph, everyone. So in this graph, if you observe, if I draw a graph in this way, let us say if I draw any function in this particular way, okay, you see in this way, if I'm drawing the graph of a function, y is equal to f of x. Now, in this case, everyone, try to understand, if you take any 2 points, let us say this point and this point, okay, let us say this point and this point, which is going to be given by x1 and x2. Now, when here you can clearly see that x2 is greater than x1. Okay, for x2 greater than x1, can we say the value of y you're going to get at the corresponding values of x? That is, at x is equal to x1, this is the value of y you're going to get, right? And at x is equal to x2, this is the value of y you're going to get. And clearly, at x is equal to x2, whatever value of y you're getting, that is going to be higher when you compare with the value of y which you are getting at x is equal to x1. So can we say that when x2 is greater than x1, definitely the value of f of x2, if it is going to be greater than f of x1, That type of functions are basically nothing but strictly increasing functions. What do we call this type of functions, everyone? Well, this type of functions are simply known as strictly increasing functions. That is, with decrease in the value of y, with the increase in the values of x, sorry, with the increase in the values of x, if the y value keeps on increasing, that type of functions are basically called as strictly increasing functions. Okay. Now, I'll take another example for you. You see this graph, everyone. Let me take another graph for you. So let us say this is going to be your y-axis. This is going to be your x-axis. Now, let me draw the graph of a function in this way. Let us say the graph is going to be something like this. Okay. The graph is going to be something like this. So this is how the graph of the function is going to be for a certain function y is equal to f of x. Now you see here, everyone, if you take any 2 points now, let us say you have taken a point here, which is x1, and you have taken a point here, which is going to be x2. In this case, if you take x1 and x2, guys, such a way that x2 is greater than x1, then the relation you're going to get between f of x1 and f of x2, it is going to be this type of relation, this type of condition you're going to get, which is f of x2 can be greater or equal to f of x1, because you see it completely depends upon where you take the values of x1 and x2. Let us say you have taken x1 here and x2 here, then f of x2 is going to be greater than f of x1. But let us say you have taken x1 here and x2 here. यहाँ पे देखो f of x1, f of x2, that is the value of y at x1 and x2, they are going to be the same thing. I'm going to get f of x1 is equal to f of x2. So whenever you have this type of graph for which you're going to get this condition, so this type of conditions, this type of function is basically going to represent only increasing function, not strictly increasing. We basically call it as only increasing functions. Okay. So hello everyone. Good evening, guys. Good evening. So concentrate karo yahan pe. So this is the difference between strictly increasing and increasing, guys. So in case of strictly increasing, remember this is the condition you're going to get. That is, for any value of x2 greater than x1, f of x2 will also be greater than f of x1. That is, with increase in the values of x, y value also keeps on increasing. But in the case of only increasing function, this is the condition you're going to get. That is, if x2 is greater than x1, f of x2 will be greater than or equal to f of x1. So this condition is representing the functions which are going to be only increasing functions. Hi Karthikeyan, good evening, man. Sir, did I come late? No, you're right on the time. I think I just started discussing about increasing functions. So anyway, I'll quickly revise it for you. No problems. Okay. So I hope this concept is clear for you guys. So again, I'm telling you guys, increasing function. What is an increasing function? If it is going to satisfy this condition, x2 greater than x1, implies f of x2 greater than or equal to f of x1, that is going to be an increasing function. And what about a strictly increasing function? If x2 is greater than x1 and if f of x2 is going to be greater than f of x1, for that, that is going to imply that the function is going to be a strictly increasing function. So I hope this entire concept is clear for you. In fact, you see the diagram. In the diagram, you can clearly see that this graph is a strictly increasing function, not an increasing function. I can say this one here is a strictly increasing function, not only increasing function. This is going to be a strictly increasing function, because you see, for any value of x2, I mean, if you take any two values on the graph, any two values of x, for x2 greater than x1, you see f of x2 value is always greater than f of x1. So in that way, we can say that this graph is representing a strictly increasing function graph. Okay. Similarly, if we talk about the decreasing function, well, in the case of decreasing function, guys, we have the same logic. So in case of decreasing function, what is going to happen? Let me take an example, like what is going to happen in that case. So for example, you see this graph, everyone. So this is going to be your x and y axis. So now let me draw a graph in this way. Okay, let us say कुछ ऐसे graph आप देखो यहाँ पे. So this is going to be the graph of y is equal to f of x. Now you take any two x values in this case. Let us say I'm taking the value of x here and another value of x here. Let us say this is going to be x1, this is going to be x2. Now everyone observe the graph. If x2 is greater than x1, definitely x2 is greater than x1 here. But does that imply the value of y at x2 is greater than the value of y at x1? No, you see, the value of y at x1 is actually greater when you compare with the value of y at x2. So what does that mean? For x2 greater than x1, if you're getting this condition that f of x1 is greater than f of x2, then this is going to indicate which function, everyone? Well, this is going to indicate a strictly decreasing function. What is this going to indicate? This is going to indicate a strictly decreasing function. So whenever you get this condition, no, that x2 greater than x1 and if f of x1 is going to be greater than f of x2, in that case, the function is going to be a strictly decreasing function. And what about only decreasing function? Well, for x2 greater than x1, if you get f of x1 to be greater than or equal to f of x2, in that case, you are going to get only decreasing function. So I hope this concept is clear for everyone, guys. Okay, so you see the diagram. If you see the diagram, guys, if you see this graph, this is indicating a strictly decreasing function or only a decreasing function. Well, definitely this is going to be representing a strictly decreasing function, right? You see, you take any two values here, any two values of x. For example, if you have taken x1 here, x2 here, the value of f of x1 is actually greater when you compare with f of x2. So yeah, this is going to be representing a strictly decreasing function. So I hope this entire concept is clear for you guys. The difference between decreasing, strictly decreasing, and also the difference between an increasing function and a decreasing function. Okay. Now, what type of questions are going to be asked in the examination on this entire concept? So now you've got to know the basic idea, like what is an increasing function going to be, what is a decreasing function going to be. So iske upar, sir, in the examination, what type of questions are going to be asked? So everyone listen to this carefully. I'll tell you what type of questions are going to be asked. A function will be given for you, okay, and he's going to ask you in which interval this function is going to be increasing, in which interval this function is going to be decreasing. This type of questions are going to be framed in this concept. So we need to have a method through which, we can decide that, acha, in this interval the function will be increasing. Acha, ye wale interval mein function is going to be decreasing. We need a method, right? So everyone, let us understand that method. What is the method we have for basically, concluding a function is an increasing function or the function going to be a decreasing function? So the method is quite simple. All you have to do is, let us say a function is given for you. Let me do it this for you guys. Let us say that a function is given for you in a certain interval. Okay, so let us say y is equal to f of x is given for you in a certain interval a b. Now all you have to do is find out f dash of x. What you'll do, you find f dash of x, guys, and see whether f dash of x value is greater than 0, greater than or equal to 0, less than 0 or less than or equal to 0 for x belonging to this interval a comma b. Okay, again I'm telling you what you need to do, that first you need to find out f dash of x value. Okay, and after that you have to check what are the different values of f dash of x you're going to get. Okay, so let us say if you're getting f dash of x going to be greater than 0 for any value of x in the interval a to b, in that case we can say the function is going to be representing a strictly increasing function. What is that function going to be? The function is going to be a strictly increasing function. Let us say you're getting this condition, f dash of x greater than or equal to 0 for any value of x in the interval a to b. If you're getting this condition, then what is this representing? This will be representing only increasing function, not strictly increasing, only increasing function. Similarly, if you're getting f dash of x less than 0 for any value of x in the interval a to b, that is going to represent strictly decreasing function. And if you're getting only this criteria that f dash of x is going to be less than or equal to 0, in this case for any value of x in the interval a to b, this will be representing only decreasing function. So I hope this concept is clear for all the students, guys. Okay. Hi Jasveer, good evening. So this is the method which you need to apply to basically identify whether a given function is going to be increasing, decreasing, strictly decreasing in a given interval. Okay, so I hope this concept is clear, guys. You can see the same method is given for you. The first derivative test for increasing functions and also decreasing function, the same type of method, the first derivative test for the decreasing functions. Okay, so let me do one thing. Let me take a question for you, and through the question, I'll show you how to apply this method, everyone. You see this question, everyone. So find the interval in which the function f of x is equal to 2x cube plus 3x square minus of 12x plus 1 is going to be increasing. We need to find out the interval in which this is going to be increasing. Now let me do it in this way. So first what I told you, let us first find out f dash of x. Okay. First what you need to do, whether to decide in which interval the function is increasing or decreasing, you need to first find out what is f dash of x going to be. So what is f dash of x in this case? 6x square plus 6x minus 12. This is what you are going to get. Okay, so from here I can write this as f dash of x is equal to 6 into x square plus x minus of 2. Right, everyone? So can we factorize this? Yes, we can do the factorization. 6 into this can be written as x square plus 2x minus 6 minus 2. So this can be written as 6 into, I can take x as a common. So x plus 2 minus 1 as a common, x plus 2. So basically I'm getting the factors in this case. If I factorize this quadratic equation, I'm getting the factors as x minus 1 into x plus 2. This is what you're going to get. Now we need to decide in which interval for what values of x this function f of x is increasing, for what values of x the function f of x is decreasing. So we need to figure out all those things. So now all you have to do is apply the wavy curve method. I told you wavy curve method, whenever this type of inequalities are involved, guys, in that case the wavy curve method is the best method to get the solution very easily and also very quickly. So what you have to do is you can take x is equal to 1 here and x is equal to minus 2. Okay, so according to the wavy curve method, this will be positive. You have to move in this direction. Okay, you're crossing 1, the corresponding factor is x minus 1, the power is going to be odd, change the sign, this will be negative. And again you have to, then next you'll be passing through minus 2, the corresponding factor will be x plus 2, the power is odd, again you have to change the sign. So from negative it is going to become positive. So you can do it in this way, like you can basically decide what will be the sign of 6 into x minus 1 into x plus 2 depending upon the values of x, or else you can do it directly also. I mean, you see, for any value of x greater than 1, x minus 1 will be positive, x plus 2 is also going to be positive. So we can say that this is going to be positive for any value of x greater than 1. We can definitely say this entire region is going to be positive. Okay, if you take any value of x between minus 2 to 1, okay, what we can do here in this case is that you see for x equal to 0, x minus 1 is negative, x plus 2 is positive. So negative into positive, you get negative. So any value of x you take in the region minus 2 to 1, I can say that f dash of x is going to be negative there. And for any value of x less than minus 2, what is happening? X minus 1 will be negative, x plus 2 will be negative. Negative into negative, you get the positive region, I mean positive sign. So for any value of x less than minus 2, f dash of x is going to be positive. Okay, Wavy curve method in which class you taught, sir? I think you have missed it. Karthikeyan, I think, see, Wavy curve method till now, I guess in any class where I teach it, I don't think so. matlab Wavy curve method, I thought it was a very basic method which you should which you should be knowing already. But if you don't know, guys, okay, if you don't know that Wavy curve method, no problem, I'll take that up in the next class. Okay, like if you don't know, sir, हमें like Wavy curve method नहीं पता है, it's the first time we are listening to this method, or no sir, we need more clarity on that, it hardly takes 5 to 10 minutes, right? Okay, hardly 5 to 10 minutes का concept है. So we'll do one thing. I'll take that up in the next session for you. Okay, in the next session, I'll include the slides of Wavy curve method. We'll discuss it in 5 to 10 minutes. वो वाले topic भी खत्म कर लेते हैं. Okay, so no problem, no issues. Okay, so hi Santosh, good evening. So chalo guys, let us basically continue with the problem. So we got to know that f dash of x is going to behave in this particular way in this regions. Okay, now from here what we can do, guys, so we want the interval in which f of x is increasing. If f of x is increasing, f dash of x should be greater than or equal to 0. Yes or no, everyone? So can we do it in this way? So can we basically do it in this way that you see in the regions which you got, you consider the regions which is going to be positive. So see, this region is positive, this region is positive. So what does that mean? For any value of x belonging to minus infinity to minus 2, union 1 to infinity, we can say that in this interval, for this values of x, dash of x is, what is that going to become? Well, f dash of x is going to become greater than or equal to 0. So if dash of x is going to be positive, that is greater than or equal to 0, we can say the function f of x is going to be an increasing function. What f of x is going to be, everyone? Well, the function f of x is going to be an increasing function. So I hope this question is clear for everyone. Everyone understood how to find the intervals in this case. So any value of x in the interval minus infinity to minus 2, union 1 to infinity, in this interval f dash of x is going to be greater than or equal to 0. So in this interval the function is going to be an increasing function. If the question is decreasing, then you have to just conclude that any value in the interval minus 2 to 1, for those values of x, we can say f of x is going to be a decreasing function, because for any value of x in the interval minus 2 to 1, f dash of x is becoming less than or equal to 0. So that is why for this region, the function will be decreasing. For this regions, these two regions, I can say the function is going to be an increasing function. So this is how you have to apply the concept, everyone. So what you need to do whenever you have a question on increasing or let us say decreasing function, okay, the monotonicity of a function, if you get a question from that concept, what you have to do, first find out f dash of x, okay, and accordingly you see what f dash of x you got, and accordingly decide in which interval f dash of x is positive, in which interval f dash of x is going to be negative. Accordingly, you are going to get the regions in which the functions are going to be increasing or the functions are going to be decreasing. So I hope this question and the concept of increasing and decreasing function is clear for all the students, guys. So now let me do a question. Actually, this is a previous year question, guys. I think it's a JEE Main 2019 question, Shayad. Okay, so I want everyone to look at this question. Everyone concentrate here. So in this question, what is given for you? It is given that g of x is given f of x plus f of 1 minus x. What is g of x given? F of x plus f of 1 minus x. And also it is given that f double dash of x is greater than 0 for any value of x. F double dash of x is greater than 0 for any value of x in the interval 0 comma 1. What we need to do, we need to find the intervals in which the g of x is going to increase and decrease. So yeah, both interesting question. I want everyone to concentrate. First thing, let us understand this condition given. Okay, you see the condition given for you, which is f double dash of x is greater than 0 for x belonging to 0 to 1. Now can we say that if f double dash of x is greater than 0, can we say f dash of x is going to be an increasing function? Can we conclude that? Yes, we can do that because see, it's similar. I'm sorry, it's similar to saying like this, like basically if f of x is a strictly increasing function, then f dash of x is going to be greater than 0, right? Similarly, if f dash of x is a strictly increasing function, similarly, if f dash of x is strictly increasing function, if f dash of x is a strictly increasing function, we can say that f double dash of x is going to be greater than 0, right everyone? So this is the first conclusion which we can make, which we can which we can make in for using this condition given. Now g of x is given, so let us find out the first case here. Let us say case number a. Let me find out the interval in which g of x is increasing. Okay, so let me do that first for you. So for that, what I'll be doing here is that let me find out g dash of x. What is g dash of x going to be? Well, it is going to be f dash of x, okay, plus f dash of 1 minus x into minus 1. This is what you're going to get. Now, when g of x, I'm taking it as an increasing function. G dash of x kya hoga? Well, it should be taken greater than or equal to 0, right everyone? So from here, I'm going to get f dash of x to be greater than or equal to f dash of 1 minus x. That is what you are going to get. Now we already know that this f dash of x is going to be a strictly increasing function. So what does that mean? Well, we have this logic, no guys, that when x2 is greater than x1, then f of x2 is going to be greater than f of x1 for a strictly increasing function. Yes or no? Like for example, let us take a random function called h of x. If let us say if h of x is going to be a strictly increasing function, then can we say it is going to satisfy this logic that if x2 is greater than x1, then h of x2 is also going to be greater than h of x1, right? Then only we can say h is going to be a strictly increasing function. So if f dash of x is greater than or equal to f dash of 1 minus x, this simply means x is should be greater than or equal to 1 minus x, because the function f dash is going to be a strictly increasing function. So from here, I'm going to get 2x to be greater than or equal to 1, or I can write x to be greater than or equal to 1 by 2. So guys, आप देख सकते हैं यहाँ पे, so therefore x belonging to 1 by 2 to don't take infinity, because we need to consider the values of x only in the interval 0 to 1. So any value of x lying in the interval 1 by 2 to 1, we can say for this interval, the function g of x is going to be an increasing function, guys. Similarly, if you go with the second case, the case where the function g of x is going to be decreasing, तो यहाँ पे आप क्या करेंगे? Again the same thing. You have to find out g dash of x, which is going to be f dash of x minus of f dash of 1 minus x. So if g of x is going to be a decreasing function, what is g dash of x going to be in that case? Well, that is going to be less than or equal to 0. So from this, you're going to get this condition. F dash of x is going to be less than or equal to f dash of 1 minus x. Now again, you have to use the logic of increasing function, strictly increasing function, that if x2 is greater than x1, then h of x2 will be greater than h of x1. Similarly, I can write down if f dash of 1 minus x is greater than or equal to f dash of x, then 1 minus x will be greater than or equal to x, because again, the reason is simple, because the function f dash is going to be a strictly increasing function. So from that, what am I going to get, everyone? I'm going to get 2x to be less than or equal to 1, or x is going to be less than or equal to 1 by 2. So from here, what is the value? What are the values of x I'm going to get? X belonging to the lower limit is going to be 0. So any value of x lying in the interval 0 to 1 by 2, we can say in this interval, the function g of x is simply going to be decreasing. So I hope this entire question is clear for all the students. Anyone is having any doubt in this question? Got it? So guys, in this question, we have used the concept of increasing function, decreasing function, the basic definition of increasing and decreasing, and also the method, which is f dash of x greater than 0, f dash of x less than 0 for increasing and decreasing. We also have used the method. So it's a good question, which is going to be dependent on the concept of the basic concept of increasing and decreasing function. So with that, let me go to another concept, which is going to be related to properties of monotonic function. So guys, if you want to discuss, if you want to know about the properties of monotonic function, so let us say that you have two functions given for you. F and g are going to be two functions given for you. Now, depending upon whether f and g are going to be increasing or decreasing, you can decide f plus g, f into g, minus f minus g. You can decide whether they are going to be increasing, whether they are going to be decreasing. So for a simple example, let us say if f and g are going to be both increasing functions, then remember guys, f plus g is also going to be increasing. This arrow mark here, this upside arrow mark is going to be indicating increasing function, guys, and this downside arrow mark is going to indicate decreasing function. So don't get confused. Okay, so if f and g are going to be increasing, remember f plus g is also increasing. If f and g are going to be decreasing, remember f plus g is also decreasing. And again, there is no rocket science logic in this case. Very simple. If you see this, if you find f plus g whole dash, no, you get f dash plus g dash, guys. This is what you're going to get, right? Now, what I'm saying is that if f and g are going to be increasing functions, f dash is going to be greater than 0, g dash is going to be greater than 0. So basically the right hand side term will become greater than 0, right? So I'm getting f plus g whole dash to be greater than 0. So what does that mean? Well, f plus g is also going to be an increasing function, right? So that is what we are doing here. So if f and g is increasing, f plus g will be increasing. If f and g is going to be decreasing, f plus g is also going to be a decreasing function. So that is the first important logic for you, the first property. The second property, if f is increasing, then minus f will be decreasing function. And if f is a decreasing function, minus f is going to be an increasing function, guys. And then if f and g are going to be increasing, and let us say f and g both are going to be greater than or equal to 0 for any value of x, or let us say for the given values of x, okay, then remember, if you find f into g, that is also going to be increasing. And let us say similarly, if you take f and g to be decreasing, then f into g is also going to be a decreasing function. So that is going to be the third property. You can actually make use of these properties and directly conclude about certain functions, whether they are going to be increasing functions or decreasing functions. And I'll take an example to make you understand what I'm basically telling you. So for example, let us say y is equal to f of x is equal to x into sin x is given, man, okay, and in the interval x belonging to the interval 0 to pi by 2. Now if I want to decide whether this function in this interval is going to be an increasing function or decreasing function, like one way, you have your standard method with you where you'll apply f dash of x, and from that you'll get to know whether it's going to be increasing or not. Okay, or else आप यहाँ पे directly property भी use कर सकते हैं. You see here, guys, in the interval 0 to pi by 2, well, x is always an increasing function. In the interval 0 to pi by 2, sin x is also increasing. And also we know for any value of x in the interval 0 to pi by 2, x is always greater than 0. In the interval 0 to pi by 2, sin x is always greater than 0. Okay, so what does that mean, everyone? So we can apply the third property, that if f is increasing, g is increasing, and if f and g both are going to be greater than or equal to 0, then what about f into g? Well, f into g is also going to be an increasing function. So directly we can conclude here, we can write down that f into g is also going to be, that is in this case f of x, is also going to be an increasing function. So see, we can use the property and directly conclude about this type of functions using these properties, guys. So I hope this question is clear for all the students. So now let me go to another question. You see this question now. The function is given for you, f of x equal to 3x plus 5. Let f inverse of x is existing. Okay, what can be said about the monotonicity? Yeah, sorry for that, guys. Yeah, so what can be said about the monotonicity of f inverse of x? So everyone look at this question, another interesting question. So if f of x is going to be an increasing function, then what about f inverse of x? Will it be increasing? Well, let us check it out. First thing, guys, what is given? Y is equal to f of x is equal to 3x plus 5 is given, no? So in this case, if you find out dy by dx, no, you're going to get the value as 3, which is always greater than 0. So what does that mean? Well, if dy by dx is given, if the dy by dx is greater than 0, we can say the function f of x is definitely going to be what? A strictly increasing function. Yes or no? We can say the function f of x is definitely going to be a strictly increasing function. Okay. Now, if you want to find out the inverse of the function, you can do it in this way. So to find the inverse, you need to write x in terms of y. I'm going to get 3x is equal to y minus 5, or I can write down x to be equal to 1 by 3 into y minus 5. Now we do know that x is simply nothing but f inverse of y. So from here, you're going to get f inverse of y to be 1 by 3 into y minus 5. So from here, guys, what is f inverse of x going to be? It is going to be 1 by 3 into x minus 5. Now, if you observe this equation which we got, no, yahan pe, guys, you tell me, is this going to be an increasing function? Well, you check this out. Let me differentiate the equation which we got. If you're differentiating dy by dx, if you're finding dy by dx, you're going to get 1 by 3, which is also greater than 0. So what does that mean? Well, f inverse of x is also going to be a strictly increasing function. So from this, let me tell you one very important point, guys. Remember, if f of x is going to be a monotonic function, increasing ho ya decreasing ho, strictly increasing, strictly decreasing. But remember that if f of x is going to be a monotonic function, then f inverse of x is also going to be a monotonic function. You need not to actually, check that, cross check that. आप directly conclude कर सकते हैं वहां पे. So अगर कोई भी function, you take any function, if it is a monotonic function, if the inverse is going to exist for that function, जो भी inverse मिलेगा ना आपको, whichever inverse you're going to get, well, that is also going to be a monotonic function. So I hope this entire concept is clear for all the students, guys. Now let me go to another property. Now this property is related to the which one? The composite functions, guys. Now remember, let us say that f and g functions are given, and let us say f circle g, g circle f is going to be defined. Okay, so if f and g are going to be increasing, can you decide anything about f circle g? Can you decide anything about g circle f? Guys, trust me, this type of concepts are very important for doing few questions. I'll show those questions for you. You'll only be surprised that by using this type of concepts how easily we can get the solution. Okay, now everyone listen to this carefully. Anyway, so basically whenever you have an idea of the function f and g, whether it's going to be increasing, whether it's going to be decreasing, then can you conclude anything about f circle g? Can we conclude anything about g circle f? Yes, we can do that. Well, it all depends upon the table. You see this table, everyone. And also I tell you how to remember the table. Okay, I'll tell you a very simple technique for that. You see, when f is increasing, g is increasing. If f is increasing, g is increasing, f dash of x will be greater than 0. G dash of x is going to be greater than 0. Then remember, guys, f circle g and g circle f is also going to be an increasing function, because if you find f circle g dash of x or g circle f dash, in that case, whatever result you're going to get, that is going to be definitely greater than 0. Remember that, everyone. Okay, and the logic is very simple. Yahan pe again, it's not rocket science. Okay, I'm applying a very simple logic. So what I'm doing is basically, if you take f circle g of x, no guys, let us say f circle g of x, okay, which is going to be f of g of x. So when you differentiate f of g of x, this is what you're going to get. You're going to get f dash of g of x into g dash of x. This is what you're going to get. Now, if f dash of x is increasing, g dash f dash of g of x will also be an increasing function. G dash of x, if it is increasing, I mean g of x is increasing, then g dash of x is also going to be greater than 0. So this is greater than 0. This is greater than 0, then definitely we can say that f circle g of x, we can say f circle g whole dash is also greater than 0. If f circle g whole dash is greater than 0, you tell me what about f circle g function? Well, that is also going to be an increasing function. Right, everyone? I hope this point is clear for you. Okay, so through that only we are able to basically get this table. So remember, guys, if f is going to be increasing, in fact, I'll write down a much more simple table for you. You remember this table, guys, rather than remembering f dash of x and g dash of x, everyone. Remember, let me write down for you f, g, f circle g and g circle f. I want everyone to pay attention here. So remember that if f is increasing, g is increasing, then f circle g is also going to be increasing function. G circle f is also going to be increasing. If f is decreasing, g is increasing, then remember f circle g will be decreasing, g circle f is also going to be decreasing. And the same thing, let us say that if f is increasing and g is decreasing, you end up getting the same result, that f circle g will be decreasing, g circle f will be decreasing. And if f is decreasing, g is decreasing, remember f circle g will be increasing, g circle f is going to be increasing. So like what I do is I remember this in this way. Positive into positive is equal to positive ही होगा. Right. So that is why you see when f and g are increasing, f dash g dash is greater than 0. So f circle g is also increasing, g circle f is also increasing. So you remember in this way, positive positive मतलब increasing के लिए you keep positive in your mind, decreasing के लिए you keep negative in your mind. Okay, so positive into positive, it's always positive. So f circle g increasing, g circle f increasing. Negative into positive is always negative. So f circle g decreasing, g circle f decreasing. Again the same thing. If f is increasing, g is decreasing. So positive into negative, again negative. So f circle g decreasing, g circle f decreasing. And if f is if f is decreasing, g is decreasing. Negative into negative, it's going to be positive. So what does that mean? Well, f circle g will be increasing, g circle f will be increasing. So through that, you can easily remember this properties of monotonic function for the composite functions, guys. So now let me show you the application part. Now you see this question. Find the interval in which this function is a strictly decreasing function. Okay. Now I want everyone to understand that in this question, when you see this function now, guys, so अगर आप function देखेंगे, what is the function given? F of x is equal to tan inverse of log of x to the base 1 by 3. This is a composite function. Agreed? I think everyone agrees with me that, yeah, this is a composite function. This is going to be a combination of two functions. Well, the one function is going to be tan inverse x and another function is going to be which one? I can say log x to the base 1 by 3. Now you need to understand, guys, you need to understand that tan inverse x, can we say that it's going to be always an increasing function? Can we say tan inverse x? Because you know, if you take tan inverse x to be y, if you find dy by dx, no guys, it's going to give you 1 by 1 plus x square. And for any value of x belonging to real number, if any value for any value of x, okay, belonging to for any value of x belonging to real number, we can say that 1 plus x square is always greater than 0, right? So we can basically say that tan inverse x is definitely going to be an increasing function. It's always going to be an increasing function. And you tell me, what about log x to the base 1 by 3? Log x to the base 1 by 3. Well, you know, related to logarithm, I told you one very, very important point. What was that, guys? Very simple. Let us write down. Let me write it down for you. Okay. When you take log x to the base a, no, when a is going to be greater than 0, that function is going to be an increasing function. I mean, you get this type of graph, guys. आपको ऐसे type of graph मिलेगा for a greater than 0. And when you take a to be, let us say, between 0 and 1, a cannot be less than 0. Don't take the base to be 0. I mean, or less than 0. वहाँ पे it's not going to be defined. So if you take a to be 0, a to be between 0 to 1, in that case, guys, you end up getting this type of graph. You see, you're going to get this type of graph when a is going to lie between 0 and 1. So you see, in the second scenario, the function, the logarithmic function will be a decreasing function, not an increasing function. So what is this going to become? Well, this is going to be decreasing. I can say log x to the base 1 by 3 is definitely going to be a decreasing function, okay, for x belonging to only positive real numbers, because log hai, to yahan pe you can't take all the real numbers, you have to take only positive real numbers. So one function is increasing, another function is decreasing. Then what about the composite function of them? What about the composite function of them according to this table? You see this table, everyone. So according to this table, what is the result you are going to get? I told you, if f and g may, if at least one function, I mean, if one function is decreasing, so positive into negative kya hoga? Negative hi hoga. So it's going to be decreasing only. So we can say that, well, definitely the function f of x is going to be decreasing. And for what values it is going to be decreasing, everyone? It is going to be decreasing for x belonging to positive real numbers. You take any value of x, because यहाँ पे देखो, because you see x is only, I mean, x is basically inside log, and log is defined only for positive real numbers. So you take any positive real number, f of x is definitely going to be decreasing. So I hope this entire concept is clear for all the students. In fact, not only this question, you can take any other question. For example, let me take another question for you. मैं यहाँ पे लिख देता हूँ आपको. You see, if I ask you a question like this, let us say f of x is equal to sine of sine x, yeah, sine of sine x, okay, in the interval, let us say 0 to pi by 2. In the interval 0 to pi by 2, I've taken sine of sine x. You tell me, is this going to be an increasing function? Yes, this is definitely going to be an increasing function. Reason is quite simple. If you see, sine of sine x is going to be again a combination of two functions, which is sin x and sin x, right? Now sin x is an increasing function in the interval 0 to pi by 2. Sin x is increasing, another sin x will also be increasing. So increasing, when f and g both are increasing, f circle g is also increasing. So we can say yes, sine of sine x is also going to be an increasing function. So in this way, whenever you find this composite functions now, guys, and if you want to decide whether it's going to be, increasing or decreasing, you can apply this particular property. Okay, let us say, guys, if you're not able to apply the property, or if you don't have any idea about the individual functions which are involved in the composite function, in that case आपके पास तो method है ना. Method तो कोई भी question में, in any question where you want to find out where increasing and decreasing function concept is involved, you can apply that method in any question, guys. In any question where increasing and decreasing concept is going to be involved. So method आपके पास है already. Okay, you can apply the method and get the same answer. But using these properties, guys, you'll get the answer, within actually much more easier and within a very short time. Okay, so I hope this concept is clear for all the students. So now, if you see, related to monotonic functions, guys, we have discussed all these things in detail. So right, we have discussed how its behavior going to be, behavior of the function and its inverse. We have discussed about the behavior of composite functions. Now one topic is left out, which is comparing the functions. Yes, you heard me right. We can use the concept of increasing functions to compare the functions, guys. So let me tell you, like, how can we do that, how to do that, all that stuff. Let me discuss that in a very detailed way. Okay, so for example, you see this particular question, guys. Find the order relation between x and tan inverse x when x is going to belong to the interval 0 to infinity. So basically, if I give you the numbers like 3 and 2 and tell me what is the order relation you're going to get, well, that's a very simple question. No, you'll say, sir, 3 greater than 2. Or let us say I'll give you 10 and 11. What is the order relation going to be? Sir, 10 less than 11. So that is easy. So when you want to compare the numbers, that's a very easy task for you. Right? But if I give you two functions and I've given you an interval also, and I'm asking you, compare karo and tell me which one is the higher one, which one is the lower one. Now the problem starts because you can't take like in the interval x belonging to 0 to infinity. How do you compare? How would you know that whether x is going to be greatest or tan inverse x is going to be greater? Well, for that we can use the concept of the calculus method, that is the monotonic functions method. So guys, what you have to do is whenever you want to compare two functions, in that case you first take it in this way. F of x, wahan pe you write it in this way. You take the difference of the two functions which you have to compare. Okay, so I need to compare x and tan inverse x, so take the difference of them. So let me take that as f of x. F of x is equal to x minus tan inverse x. Now what you are going to do is that now you find out whether f of x is going to be an increasing function or a decreasing function in this particular interval, everyone. Okay, so how do we do that? Very simple. We know the method, right? We'll find out f dash of x and we'll see that. So let me find out f dash of x. F dash of x is going to be 1 minus 1 by 1 plus x square. So from this I'm going to get f dash of x. What is that going to be, guys? Well, if you take the LCM, I'll get 1 plus x square minus 1 divided by 1 plus x square. 1 and 1 is getting cancelled. So I'm getting f dash of x to be equal to x square by 1 plus x square. And tell me, for any value of x in the interval 0 to infinity, guys, numerator is always positive, denominator is always positive. So can we say f dash of x is always greater than or equal to 0 for any value of x in the interval 0 to infinity? So what does that simply mean? What does that simply mean? If f dash of x is greater than or equal to 0 for any value of x in the interval 0 to infinity, this simply means that the function f of x is going to be an increasing function. We can conclude that the function f of x, what is that going to be? It is going to be an increasing function. So if f of x is increasing function, so हमें तो यार we have learned, in fact in today's session only we have seen that basic concept that if x2 is greater than x1, then f of x2 is also going to be greater than f of x1 if f of x is going to be an increasing function. Yes or no, everyone? If f of x is an increasing function, then for any value of any two values, x2 greater than x1, then we can say f of x2 will be greater than or equal to f of x1, where an x1 and x2 are going to belong to the interval given. So according to that, I can write down when x is greater than 0, I can write f of x is greater than or equal to f of 0. So when f of x, we know it is x minus tan inverse x. Okay. And what is f of 0 value going to become, guys? F of 0 is 0 minus tan inverse 0 is 0. So from this inequation, I'm going to get x to be greater than or equal to tan inverse x. So this is the order relation you're going to get. So if you exclude the 0, for other values, I can say x is going to be greater than tan inverse x. So I hope this concept is clear for all the students. Anyone is having any doubt in this question? So guys, always remember, whenever you want to compare two functions, what you have to do, you take a function, okay, which is going to be the difference of two functions. You identify, you find out that function which you have taken as a difference of two functions in the question given for you. Okay, you identify whether that function is going to be an increasing function or decreasing function for the given interval in the question, and according to that you apply the basic concept. If it is increasing, apply the basic concept of increasing like this. If it is decreasing, apply the basic concept of decreasing. And from that, you are definitely going to get the relation, the comparison between the two functions. Okay, so I hope this question is clear for all the students, guys. So now what we will do, let us talk about the concept of local maxima and local minima. So I want everyone to pay attention here. What is this concept going to be about the local maxima and local minima? And to understand the concept, no, I'll give you a very simple diagram to make you understand the entire concept of local maxima and local minima. Okay. Now, everyone, I want you guys to look at the figure in a certain interval. Let me take the interval first. Let us take the interval x is equal to a to x is equal to b, and between x is equal to a to x is equal to b, let me draw the graph in this way. Let me take a random graph. Okay, so let me say the graph is going to be something like this. Okay, the graph is going to be something like this. Okay, so the graph is going to be, yeah, something like this. So let us say this is how the graph of y is equal to f of x is going to look like. Okay, so interesting graph. I don't know which equation will have this type of graph. Yeah, definitely some equation will be having this type of graph. Okay, but yeah, this is going to be the graph of y is equal to f of x. Now, guys, you need to understand what is local maxima and local minima. And see, you stress upon the word local. You know, there is a reason we call it as local maxima and local minima. Okay, so guys, what you need to understand about local maxima and local minima is that if you see this point, I want everyone to observe this particular point. You see this particular point here. You see this particular point here, guys. So let me do one thing. Let me not take this dotted lines. Yeah, if you see this particular point here, let us say x is equal to b. At x equal to b, what is happening is whatever value of y you're going to get, it is actually the highest value when you compare it with the neighborhood values. When I talk about neighborhood, when I mention the term neighborhood, neighborhood values का मतलब क्या होगा कि the values of y which are very close to this value of y at x equal to b. So like basically if you take the values of x very close to x is equal to b on both the sides, like for example this value or this value, you don't take this value, this will not be in the neighborhood of x equal to b. As I told you, neighborhood of x equal to b का मतलब क्या हो गया कि values of x, okay, which are very close to x equal to b on both the sides. So you can take this value or this value, this value. At all those values, if you compare, if you see the y values you're going to get, see, this is the y value getting here, this is the y value getting here, this is the y value getting here. So if you compare all these y values, no, at x equal to b, you're basically getting the maximum value. So it's like what I can tell you. So for example, let us say, like I can give you a very simple example to make you understand, guys. So let us say that exam is conducted, okay, and let us say that from your school, okay, you are the top student, you have scored the maximum number of marks in that particular test, and let us say that exam paper is the same throughout the entire country, throughout India, same ही paper था, okay. So from your school you were the maximum score, you got the maximum score in that paper, okay. But that does it make it, but does it make it but that is it, like, can you conclude that you have scored the maximum in the entire country? No, in your school your score is maximum, but when you consider the entire country, there might be other school students also who might have gotten more than you. So what I can tell you is that you are like a local maxima guy. So what happened is that in your own school where you're local, okay, you got the maximum marks. So that is the concept of local maxima. So basically local maxima ke liye, you need not to worry, because you might be having this doubt, sir, because you see y value is not the highest value in the interval a to b. Definitely highest value यहाँ पे है. It's not the highest value, but still this we can see it as a local maxima, because the value of y which we are getting at x is equal to a, sorry, x equal to b, is comparatively, you know, larger when you compare it with the neighborhood values, okay, of x is equal to b, whatever values of y you're going to get for the neighborhood values of x equal to b, if you compare it with that, definitely the y value at x is equal to b is going to be the highest. So that is going to be the concept of local maxima, guys. Similarly, you see, this is going to be another point where we are going to focus upon. Now, if you compare this point, let me take this point to be, let us say x is equal to, अच्छा already मैंने यहाँ पे x equal to b use किया है ना. We'll do one thing then. Let me take this to be x equal to c. Okay, let me take this to be x equal to d. Now, when you compare x equal to d के पास y value with the y values for the neighborhood values of x, for x equal to d. So neighborhood values of x equal to d, matlab, let us say this value or this value, this value. So at all these values, if you see the values of y which you're getting, so definitely यहाँ से what is the conclusion you can make? Well, definitely we can say that yeah, y value at x equal to d is the minimum one. Yes or no? Because you compare this value at x equal to this value. See, the y value is this much. X equal to this value, the y value is this much. So at x equal to d only, I can say the y value getting is minimum. So is this the complete minimum value in the interval a to b? No. In that way, I can say that यहाँ पे आपको minimum value मिलेगा. In the entire interval a to b, at this point, you are going to get that minimum value. But if you compare this x equal to d, at x equal to d, the y value with the neighborhood values, then yeah, definitely at x equal to d, whatever the y value you're getting, that is the minimum. So we can say that x equal to d is having the local minima. So x equal to c is a point where you have the local maximum, and x equal to d is a point where you are going to have the local minimum. So guys, I hope this concept is clear for you. So how to identify local maximas and local minimas. So the diagram, from the diagram, it's going to be clear for you. So whenever you see this peak point, no, it's always the peak point is always a local maxima. And whenever you see this point, like, peak minimum value, minimum point, it's always going to indicate a local minima. Okay. So I hope this entire concept is clear for you, the concept of local maxima and a local minima. Now let us understand the method of finding the local maximas and local minimas. And we have two methods for that. We have the first derivative test and we have the second derivative test. I'll tell you in detail what is first derivative test going to be, what is second derivative test going to be. So everyone listen to this carefully. So before we discuss about the first derivative test and second derivative test, guys, let me tell you what is the concept of critical point going to be. So critical points are going to be the points where f dash of x is going to be 0, or f dash of x does not exist, or f of x does not exist. All these points are basically known as critical points. And remember, at a critical point, you might have a local maximum. It might be a point of local maxima. It might be a point of local minima, or it might be a point of inflection. This point of inflection, we'll discuss it later. Okay, not right now. But remember that at a critical point, you are going to get any of these three conditions. Okay, that point can be a point of local maxima, or a point of local minima, or a point of inflection. So whenever you want to find the critical point, all you have to do is find f dash of x, equate it to 0. From that, you're going to get the critical points. Observe the f dash of x equation. You see where f dash of x is not existing, those points are also termed as critical points. Or observe the function itself where you see f of x, wherever it is not existing, whichever point it is not existing, those points are also going to be the critical points. So I hope this concept of critical points is clear for you. Now coming to the concept of which one, the first derivative test. The first derivative test के लिए all you have to do is, everyone look at this. For example, let us say that let us see this diagram, guys. Through this diagram only, in fact, I remember this concepts of first derivative test and second derivative test through the diagram only. So let us say, let me take a curve in this way, which is having a kind of local maxima. So you observe here at this point, you do have a local maximum, right everyone? Now, if I draw tangents at 2 points, one point which is going to be left side of this point, let us say if this is x equal to a, let me draw a tangent somewhere in this region. You see this tangent everyone. So this is how the tangent is going to be. Okay, I'm just drawing a rough diagram. And let me draw a tangent to the right side region. So somewhere here, let me draw another tangent. So that tangent is going to look something like this. Now observe the slope of the tangents everyone. You see the right side region के लिए the slope is going to be, can I say it's going to be positive? Can we say the right side region, or sorry, the left side region, whatever tangent you have drawn in the left side region, no, left side of x equal to a, for this tangent, the slope is going to be, which is dy by dx, it is going to be greater than 0. How do you know that? Very simple. Now you see the angle made by this line with any horizontal line, okay, it's always going to be an acute angle. Acute angle theta, tan theta is positive. Slope is positive. Dy by dx is positive. Similarly, if you see the tangent on the right side region, right side of x equal to a, what is happening, guys? You see again with respect to a horizontal line, the angle that is made by this tangent is obtuse. If theta is obtuse, tan theta is going to be negative, and if tan theta is negative, slope is now going to be negative. So dy by dx is going to be less than 0. So if dy by dx is changing the sign from positive to negative, remember this everyone. If dy by dx changes the sign from positive to negative around a critical point, we can say that at that particular critical point you have a local maxima. Okay, similarly, let me go to with another concept. Similarly, let me also discuss with you another important point. Similarly, if you go with this diagram, let us say if you go with this particular diagram, let us draw a diagram in this way now. Okay, let us draw a diagram in this way. Now you can clearly see that at this point you have a local minima. Now let me get a condition for that. Okay, through a condition, let us prove the same. So let us say this point is going to be x is equal to b. Okay, this point is going to be x is equal to b. Now to the left of x equal to b, if you draw a tangent, the tangent is going to look something like this, no man. So let me draw a tangent here, something like this. And let me draw a tangent to the right side of x equal to b, so something like this. Now you observe here, what is happening in this case, everyone? Again, if you see the tangent on the left side of x equal to b, the tangent for that tangent, the slope is negative because obtuse angle. So यहाँ पे dy by dx is becoming less than 0. And to the right side tangent, you see the angle it is making, the angle that is made is acute. So dy by dx is going to be positive in this case, everyone. So if the sign is changing from, now from here, you'll get to know that if the sign changes from, if the dy by dx sign changes from negative to positive around a critical point, then remember at that critical point, what are you going to get? You are going to get a local minima. So to sum it up, guys, in the case of first derivative test, to find out the local maxima and local minima, in the case of first derivative test, what you need to understand is that you first have to find the critical point. So how do you find out the critical point? So function will be given. Y is equal to f of x. The function is going to be given for you. Okay. So what you will do, you figure out what is f dash of x going to be equated to 0. So from this, what are you going to get? You are going to get the critical points. After getting the critical points, what you have to do is you have to check how this f dash of x, how dy by dx is changing its sign around the critical points. If it is changing from positive to negative, then wahan pe you are going to get a local maxima. If it is changing from negative to positive, in that case you are going to get a local minima. So guys, this is going to be the concept of the first derivative test in detail. Okay, so I hope this is clear for everyone. And then we have another concept which is going to be second derivative test. In the case of second derivative test, now this is very easy. I'll tell you in detail what is second derivative test going to be. So guys, everyone listen to this carefully. I think already we are 10 minutes, I think 10 minutes तो हो गया, extra 10 minutes हो गया. I'll just take 5 minutes extra guys and then I'll wind up the session. In fact, second derivative test के बारे में we'll discuss it in a much more detailed way in the next class. So no problem. Okay. So second derivative test में basically what you are going to do is that I'll just give you a very quick revision of what is second derivative test going to be. So in the case of second derivative test, what you need to do is that the function will be given, no, y is equal to f of x. So what you will do, find out f dash of x and you equate it to 0. So from this, what are you going to get? You are going to get the critical points. Okay, तो यहाँ से आपको क्या मिलेगा? You are going to get the critical points. So after getting the critical points, what you can do is that you find out the f double dash of x value at those critical points. Let us say out of all these critical points, x is equal to a is one of the critical points. Okay. So now what you'll do, you find the value of f double dash of x at x is equal to a, at x is equal to the critical points. Now, according to the value which you get, we can decide whether you have a maxima or a minima at that particular critical point, everyone. So let us say if f double dash of x value at x equal to a turns out to be greater than 0, this is simply going to indicate that at x is equal to a, you are going to have what? You are going to have a local minima, guys. And if you get f double dash of x at x is equal to a to be less than 0, in that case, what are you going to get in that particular case, everyone? Well, in that case, you are going to get at x is equal to a, you are going to get a local maximum. And finally, if f double dash of x at x is equal to a is going to be equal to 0, if it is going to be 0, in this case, what we need to do? Well, simply find f triple dash of x value, guys, at x is equal to a. If this is not going to be equal to 0, no, then you can conclude that at x is equal to a, you have neither a local maxima nor a local minima. We can say neither local maxima nor local minima or minima. This is what you can conclude. So this is going to be the second derivative test. So what you have to do in the case of second derivative test, function is given, differentiate that function, equate it to 0. From that you're going to get the critical points. Then you find f double dash of x value at those critical points. Depending upon the value which you get, if it is greater than 0, then at that critical point you have a local minima. If it is less than 0, at that critical point you have a local maxima. And if it is equal to 0, you find f triple dash of x at x equal to a. And if it is not equal to 0, then you can simply conclude that it is going to have a neither local maxima nor a local minimum at that particular point, everyone. And don't think about, sir, what happens if triple dash of x also is going to become 0. Okay, I can tell you the condition for that. But guys, it is not required for you. Okay, in your syllabus, I think if you know till f triple dash of x at x equal to a not equal to 0, if you know this till this particular condition, I think that would be enough for you for the JEE examination. Okay, so guys, what we'll do, let me quickly do a question based on this concept so that आपको भी पता चल जाएगा how to apply this concepts, everyone. And after that, I'll wind up the session today. So you see this question, everyone. Discuss the extremum of this function given. So in this case, what we'll do, as I told you, first find f dash of x. So what is f dash of x going to be here? It is going to be sine x into differentiation of 1 plus cos x is minus sine x plus differentiation of sine x is going to be cos x into 1 plus cos x. So this is what you are going to get, everyone. So from here, I'm going to get minus sine square x. Okay, minus sine square x plus, well, this is going to be cos x, right, everyone, plus cos square x. And we do know cos square x minus sine square x is going to be cos 2x plus cos x. So this is going to be your f dash of x. So from here, I can write down f dash of x is going to be, if you apply cos c plus cos d formula, you're going to get 2 cos c plus d by 2. So 2 cos 2x plus x, that is 3x by 2, and cos c minus d by 2. 2x minus x is going to be x by 2. and you can equate this to 0 to figure out what are the critical points going to be. So guys, from here, if cos 3x by 2 is going to be 0, that is only going to be possible when 3x by 2 is going to be equal to pi by 2, right? So 2 and 2 is getting cancelled. So the value of x which you're going to get in this case will be pi by 3. Okay, so for x equal to pi by 3, and again another condition which you're going to get is cos x by 2. If it is 0, then x by 2 is going to be equal to pi by 2, and you're going to get the value of x to be equal to pi, and this is not possible. And guys, remember, क्योंकि यहाँ पे क्वेश्चन में whatever value of x we need to take, it should lie in the interval 0 to pi by 2, and because this pi does not lie in the interval 0 to pi by 2, you should not take this one. You only consider this critical point, everyone. So at x equal to pi by 3, we need to discuss, we need to decide whether we are going to get a local maxima or a local minima. So for that, there are going to be two methods. You can apply the first derivative test or second derivative test. So let us say, let me go with the second derivative test in this case. To apply the second derivative test, first what you'll do, you find out f double dash of x. That is, you differentiate this function. So cos 2x differentiation is minus 2 sin 2x. Okay, and cos x differentiation is going to be minus sin x. Now find the value of this f double dash of x equal to pi by 3. You see what I'm getting here? I'll get minus 2 sine 2 pi by 3 minus of sine pi by 3. Now everyone listen to this carefully. Minus of 2 into, what is the value of sine 2 pi by 3 going to be? Sine of pi minus pi by 3. Second quadrant, sine is positive. It's going to be root 3 by 2. And sine pi by 3 is also root 3 by 2. So basically, I'm going to get minus 3 into root 3 by 2, which is going to be less than 0. So I'm getting f double dash of x, f double dash of pi by 3 value to be less than 0. So I told you, whenever the double derivative of the function at the critical point is less than 0, at that critical point, what are you going to have? A local maxima or a local minima? Well, definitely you are going to have a local maxima. So we can conclude that at x equal to pi by 3, therefore you are going to have a local maxima. So in this way, you can apply the concepts of local maxima and local minima, guys. So yeah, that's it from today's session. So guys, in the next session, that is going to be on Monday, I'll discuss about some more topics which are left out today. Okay, like point of inflection topic, and a few more questions I'll do on the concept of local maxima and local minima. In the next session, we are going to discuss the concepts of global maxima, global minima, and also nature of cubic polynomials, which are very, very important for your JEE main examination, guys. Okay, so with that, that's it from today's session. So hi everyone, good evening Yash, hello Human, hello Harman, hello Nadim. I hope everyone has understood all the topics in today's session, guys. So chalo yaar, let us call it a day today. So yeah, that's it from today's session. So guys, if anyone is still not a part of Telegram group, do join the Telegram group to get all the updates related to the classes and also exam related notifications. And if you have enjoyed the today's session, like the video, guys. Definitely like karo, share karo, subscribe karo, so that this videos reach maximum number of students who are basically looking out for some effective, very crisp and effective revision classes के लिए. I think for those type of students, this course would be very, very helpful, guys. So yeah, with that, I hope no one is having no more doubts. If anyone is having any doubt, let me know in the chat box. Is anyone having any more doubts, guys? I hope no one is having no more doubt. If you have any doubt, I'm here to help you out, guys. No doubts? Okay. So chalo guys, that's and then. Thank you so much everyone. So yeah, let us meet on Monday again. Okay, Monday we have the session at 12 p.m. So at 12 p.m. on Monday, we are going to discuss the rest of the topics in application of derivatives, like the concept of global maxima, global minima, point of inflection concept. We'll talk about the nature of cubic polynomials also in the Monday session. So yeah,